Ska vi ha your line. Put it on.
Då tar vi upp den sliden i programmet. Och sedan kör vi Niklas när jag har sagt några.
Precis, det är den här du vill ha, eller hur? Den här vill du ha, eller hur? Den här vill du ha, eller hur?
Ja, precis. Och så sen dagens schema. Kan jag få se hur den ser ut?
Den här, Wednesday.
Morning. Är det här Malin uppdaterade för typ alldeles nytt?
Ja, hon fixade den här. Det var hon som fixade senaste gången här.
Då är det fortfarande lite, den här presentationen ligger ju fel. Den ska vara där.
Vi ser om man vet om det, tror jag inte det. Men antingen säger du det eller så fixar det 3 minuter. Det är bara ni.
Men vi kör, den här presentationen är fortfarande på fel plats. Men om det här är printat så vi
Den som var detta till den.
Nej, det var...
Men då har vi 2 presentationer efter keynoten och sen har vi coffee break.
Ja.
Det är signal. Eller kanske inte så.
The morning session is split.
After the coffee break,
I will explain.
Alltså wrong. It's
I send it to him. He has slides. He has something.
Det här är dock bra att det är, eller i alla fall medan den här är kopplad till den. Varje gång hon byter slides kommer skärmen uppdateras.
Men den uppdateras?
Att då kommer den inte släckas.
Okej, det är bra.
Alltså om någonting händer.
Just det är bra.
Jag tror inte den kan släckas heller när man har kör.
Ja, men det är bra.
Sist var det för att vi bara hade streamen där.
Ja, just det.
Så vi kan...
Sen så kommer nästa talare. Kommer stänga in en dator. Så kommer behöva dra ut den här, tror jag. Men det är bra för oss nu. Vi vill bara lite koll när de pratar. För det är det borde finnas mycket. Kan vara det? Nu laddar den inte. Ja, jag pausade då inte. Jag pausade, jag började som trycka.
You should really introduce Nicholas as if he walks a walk.
This is starting to look like a really nice room with a super nice group of people, if you ask me. Good morning, everyone. Great to see you back. How are you doing today? Okay, so my name is Helena. I met with most of you yesterday. I had the pleasure to open today the second day of what is not only an SPM summit, but a conference, a workshop, great keynotes, everything. But before we start and before we run through practicalities and openings and everything, I want to start by asking you if there is any feedback about yesterday. So what do you think, people?
Great.
Yes, Chris, great. Someone else?
Great.
Did you have a good experience?
Yes. Yeah. Very. Come on, people, speak up.
Amazing.
Amazing.
Good dinner.
You enjoy the food?
Yeah, and I enjoyed the conversation
The people?
and the food.
Good. Good.
Happy to hear.
Did we kill Agile?
And we killed that.
Yes.
Okay. Okay, are we happy with that? Yes. So a few practicalities before introducing the opening keynote of today. We have a schedule, a program for today. We injected a little fold just to keep you on your toes, and that is the first session after the keynote involves this talk and this talk. So there are again 2 talks right after the keynote, and then we do coffee. Then today we also have an interactive session, because it's not only Agile that we're gonna kill, we're also asking, maybe this is the end of the product manager. The session is led by Hara. Do we have Hara in the room?
Not yet.
Not yet. He is preparing. In parallel to the first 2 presentations, there is a workshop going on. The workshop will happen starting at 10 in the room by the end of this hall. I really encourage you to look into that workshop and go there if you feel that that is something for you. So presentations here after the keynote, workshop in the workshop room. But that is not the only thing. Today is really tricky in terms of selecting where to go, because there is also an academic conference on the topic of digital product management going on. That conference, starting also right after the keynote, in a room called Decibel. It says Newton. Yeah. In the main hall, and I can even see the opening slide, which happens to be my presentation, by the way. It's there, really close. So, presentation, summit, workshop room, and academic conference. Good, we'll work it out together. There is an afternoon program as well. If we just quickly pull it up, we can say a few words. Again, here we have presentations. We have another workshop. Right after lunch, a keynote. Thank you. Pekka Abrahamsson, researcher from Finland, joining us for today. And I would really encourage everyone to be back in this room for his keynote right after lunch. I can call Jan, you won't get sleep. Presentations after that, and again a workshop running in parallel. And we also have the academic conference. Then we end the day with something called Hall of Fame session. It will be a bit of an award session, as well as a discussion on the future of this topic. And then we close. We will get to this, and then tonight there is a reception for everyone. But thank you so much. With that, I want to introduce Mr. Reinventing Automotive, as we know him, Niklas Nyckrem from Volvo Cars. Welcome on stage. And it is my privilege I have met with Niklas a few times within the Software Center context. Always been super impressed with what they do at Volvo Cars. Niklas is head of engineering, the Data Hub. And if looking at your profile, I see also titles and experiences within vehicle data diagnostics, connected experience, you name it. Super happy to have you join us here today. And I saw Niklas when he opened his slides this morning. And that always made me feel that my research slides are super boring. So welcome, Niklas. It's a privilege to have you here. And everyone, please help me out welcoming Niklas with a round of applause.
Thank you for those kind words. So standing on the shoulder of not giants, very big people in my own organization, that really are the ones that together with me driving this. So let's see if I can get actually the something to get started here.
You were showing sales projections for next year, right?
Exactly. So, and the stock market price. Let's see now. Okay. I was expecting to get a mood video up and going here. Let's see if we can get that started. There we go.
There's a brand new morning, rising clear and sweet and free. There's a new day dawning, that belongs to you and me.
Nice.
So, there we go. The new XC90, built through Agile, a bit delayed. But it will come this fall. Now, seriously, we can talk a lot about that and how to use Agile the right way and how to combine it with a well-structured top-down architectural approach as well. Let's do that for another dinner, right?
Exactly. And a lot of beer.
And a lot of beer. So, my name is Niklas Nygren. I head up something called the Engineering Data Hub in Volvo Cars. I will get back to how we construct our journey towards data analytics usage. So, data as a product or accelerating data analytics at Volvo Cars. Again, standing on the shoulders of my colleagues in this work. And it may seem when I present to you that we have come far already. We've come some bit on the way, but we have some principles that I want to show you about how we tackle this. But it will take time. It will take time because it's not a silver bullet fix in a few teams and then you're done, because you need to have this going through all of the company, making sure that all of the engineers, all the salespeople, all of the people that get access to data also know how to make sense of it and take responsibility for it. So, but let's start with our purpose, because we do have a purpose. We're a company with a purpose, and it's for life, to give people the freedom to move in a personal, sustainable, and safe way. And those who have been around for a while, understanding and knowing about the Volvo brand, you recognize many of these terms: the safety part, the sustainability part. A couple of years ago, we added also the personal part in this. But it all ties together in for life. And as you can understand, you can interpret that you never get rid of your Volvo. You keep it and you live by it for life. But it's also for life and for living. So it's about giving that extra special experience as a customer to the customer regarding personal, and it's about making the cars safe and to build the most sustainable car. The XC90 as you see, and also the XC30 recently, full electric cars, we're aiming at 2025 we'll have 50% of our sales is full electric, and by 2030 all electric cars. And all of these purpose elements require data and analytics. So for safety, for zero collisions, which is our ambition, you need massive amounts of data to be able to build the safest cars. For a stunning and personal user experience, you need to understand all about the customer, your users, and also the performance of your product in order to continuously improve it. And as for sustainability, to monitor your environmental impact, you also need data and analytics for that. And in general, to reach our target in terms of growth and profitability, you need to use data in a clever way. So all this is underpinned by data and analytics, and also technology, because we are introducing a lot of new technology in the new EX90 and coming cars. A very massive sensor set that I think you have heard about and know about, LiDAR as one important element, but also cameras and radars. So in order to strive towards zero collisions, you need a massive amount of data from the sensors to get an understanding of what's happening around you, the intentions of the surrounding traffic, the surrounding drivers, and the attention of the individual driver in the Volvo car as well, to be able to adapt safety systems, etc. And for this, you need massive amounts of compute power as well as the data. But it's all intentional, because the intention is to make sure that we build the safest cars. And we have a long history of using data to build the safest car. We've been having the accident research team for more than 50 years, researching actual incidents and accidents in the traffic by our own team of engineers. And with that, we've been able to learn from actual safety situations. So not only our well-prepared and confined crash areas in our crash labs, but also real life situations. And with active safety systems, we can actually get that data about what happened near crash or an actual crash back wirelessly to our engineering offices. So we have over 30,000 crashes that we have been investigating in crash scenes. So in the beginning, we were making adjustments to the mechanical infrastructure of the car. But now recently, we can also look at the active safety systems and work on that as well. So product technology with the intention. So since I come from engineering, I will focus a bit about engineering, but also talk about how we do it in general within all of Volvo cars when it comes to data analytics. So first of all, in engineering, we have the vision of striving towards engineering excellence and product excellence. So engineering excellence, that means that we are looking at all of the processes, all of the ways of working in engineering, and see how can we refine and improve that through data analytics. So it's about understanding what insights can and do I need to gain in order to improve and make the process more qualitative or make it more faster. So engineering excellence is one part powered by data analytics and AI. And that includes also the typical now very hard, but also very useful generative AI tools that we are using. The product excellence is about understanding the performance of the product in the real life situations. Ranging from these crash site investigations over to the wireless monitoring of the car, the functions, but also the user behavior. And then moving towards building in intelligence in the form of supporting by AI in order to build adaptable functions, intelligent functions. So engineering excellence and product excellence is what we're striving for in engineering and using data analytics. And then if we look at what kind of data is it we're talking about, at first glance you may think that it's everything that we log in the car, what's happening in the car. But actually we start with the master data. And you have everything from our drawings and code. That's basically what we deliver in engineering. We deliver drawings, CAD drawings that can be translated into parts that can be manufactured and then put together in our factories. And we deliver code. So drawings and code, that's the core. And that is the data and the master data in itself to harvest, to analyze, to understand. Then we have software configurations, information about how we put together in a certain car at a certain point in time, we have a certain software configuration. And we need that reference in order to understand what went wrong in that car as a log files afterwards. We have product lifecycle management data, how all the parts in the car is put together and configured in different, built in different ways. Their characteristics in terms of volumes to be produced and also material content. Materials data about sustainability, environmental impact, energy usage, etc. But also our test object configuration, product information, model, things like that. So a lot of data that you use as master data to reference and analyze it itself, but also combined with primary data. So the primary data is typically the observations that we make out of the product. That could be everything from crash test data in our crash labs to our rigs and test vehicle data out on the roads, but also the customer vehicle data, but also related data like mobile network data, because if we do have a problem with the connectivity or say the streaming audio, what was the actual problem? Well, it may, in many cases, be also the mobile network that were at fault. And in some cases, we're actually able to inform our mobile network operators about a bad network coverage or an outage in some area before they notice it themselves, because we're monitoring this. But weather data is also something important. If we need to understand a crash situation, what happened, it makes sense to tag that timestamp and relate that to what was the weather situation. And then our own sensors may not be the best way to do that, but rather look at the traditional weather service. So that's a couple of things around the product data. And then we have also on the process data flow, things like project plans, feature roadmaps. And the primary data after that is the observations of our project gate statuses, our fault reports, our continuous integration, continuous deployment data, etc. So all of this and many more data sources build up the data landscape that engineering has. And then if you zoom out and look at all of our cars, then you have supply chain data, you have sales data, customer relationship data, HR data, that's a lot. So in order to get this to work, we need to work across the company because sales data may also need to be combined with some of the master data about materials in order to understand what is the total environmental impact of a certain car model, a certain variant of that in relationship to the volume. So our sustainability team in some cases needs to go in and guide our balancing of our portfolio in order to be able to meet sustainability targets, for example. So it all fits together, and that's why we are running now a strategy since about a year back with 5 pillars. So it's about powering innovation in every decision with trusted data. So it's both about innovation that comes out of the correlation and relationship between different data elements to get new insights, but also make informed decisions about our product plans, about the volumes, etc., but also about technology and how to design a certain function. In that, the 5 pillars, as you see here, I will go through them a bit one by one. Federated operating model, getting this out to all of the company requires a certain, not too central-headed, but rather domain-driven approach here with support from core teams. Common data governance is really important, and as I will show, governance is a very wide term in this. Creating the data products and ensuring ownership in that, I'll talk about that. The unified data platform, and also in order to drive the change across all of the company, you need to make sure that the people are on board and understanding and doing their part in this. So let's see what we have. First of all, a federated operating model, and it's a fairly straightforward thing. We call it core, hub, and spoke. It's about having a core team that works through standards and policies and guidelines on how to have a common information model, for example, a common set of governance principles. And then you have the hubs, the blue circles, the bigger blue circles. That's the business domains. So I belong to and lead the hub for engineering. Then we have for commercial, for supply chain, finance, HR, quality. May have missed someone there, but typically each domain have their own special use cases, special business needs. And in some of them are so big. So engineering, we are around 8,000 engineers. So meaning that you need to divide that into different sub areas, and we call them spokes, basically. And in the spokes, that's where things are really happening. That's where the propulsion system, the battery and the electrical motors work. There is where the active safety systems, the self-driving and active safety systems, with massive amounts of data, have their own challenges and use cases, and so forth. And also in the commercial hub, there's also sales to digital services and things like that. And in implementing federated model, there's need to have a strong drive in each of both the hubs, but also the spokes, to take ownership of their data assets and to drive the transformation. And I will come back to that, what that means. It's both competence building, but also actually changing how we work in this. So that's the first step. The second pillar is the data governance. And it's a wide term. It's about really, data governance is about minimizing risk and maximizing business value out of the data. So building policy standards and guidelines and processes is one important thing about that. One important thing is also data quality, because as soon as you start using the data for real and trying to make those trusted decisions out of the data, you need to make sure that your quality assure the data. And the way to do that is not only or not mainly to put some filters and testing in the end of it, but really to understand and give accountability and ownership to certain teams. Your domain, your data, you're responsible. And with the federated model means that you're not only building the data for your own team needs, you're building it for the common need of the company, which means that you may need to do a bit more than you would have done if you were just using the data internally. And that's where I think many of our different hubs and spokes are today. We are not there yet to take that responsibility of actually building out the quality and the documentation of the data, what it actually means, so it can be consumed by anyone. So data quality, including also the description of the data. How is the data created and for what purpose, and what is the expected precision, latency, etc. So data quality is important, and that what I already mentioned, the ownership and the stewardship. That you own the data and you provide it as a product. And I will come back to that in the next slide. Data security is important to make sure that we, and that goes in hand with data protection as well, and we come into legislations, that we need to carefully handle the data. Some of the data is personal data coming from our customers. We are handling those data with care. We have explicit permissions or consent for the data they collect for a certain purpose. And we need to make sure that that also sort of flows through the life cycle of the data, that you can only access the data if you have the right purpose and the okay from the customer. So yeah, that's a bit about the governance part of it. Then the data as a product. Now we have, of course, a lot of data in our transactional systems and applications today. They are typically not made for providing data outside that system. It may be the source code repository, maybe the CAD systems, the PLM systems, the project management systems. You can usually export in some way into an Excel file or whatever, and even an API in some cases. It's not really built for thousands of users requesting data by the second, in many cases the same data, uncoordinated. So data as a product means that we structure the data in a certain way with an input port, with output ports, but also discoverability and observability ports, meaning that we can have ways and APIs to understand what the data is about, so that you can discover it in the data catalog and find out about the description of the data, how it's created, what's intended use, etc. And inside to have a structured way of describing how to ingest, transform, and present the data. It will be a heterogeneous system, this. And we are looking at the data mesh principle. It means that it's not one big data lake. However, I think we will derive at some point at the golden path where a couple of different systems or platforms are being used. Not hundreds, but perhaps tens of systems. So data product means also that we govern it, as I showed in the previous slide. We govern it through ownership and accountability by the domain owners. And typically, it may not be, and in many cases is not, the application owner. So if you have a PLM system and the IT department that runs the PLM system may not be the most suitable data owner, because they don't know the content, the purpose of the data in all cases. So rather than looking at the IT system owner, we are currently looking at the most knowledgeable process or domain owner for that data. And data ownership means also that you monitor and take responsibility of the data over time, adding, improving quality, improving documentation. Then the unified data platform. Wouldn't it be great to have the perfect platform to have everything? What about the data warehouse where you have all the data in one place? Well, many people have tried that. And what happens then is usually that you have a technical knowledge, domain knowledge about the platform, but less knowledge about a certain data context or domain of that. So again, I don't think we will see one platform to rule them all, but rather see this as unified data platform. I mean, it's a harmonized golden path, and it's also a co-creation of building certain parts of the data platform in certain parts of the company. So, for example, in engineering, we have massive amounts of video data and sensor data. And that's typically best handled by the engineering teams. It should be, though, a golden path of platform elements coherently put together that supports analytics, that standardize the access. So if you need to access this data from this part of the company and this data, you'd have a unified way of accessing that and have your credentials and approvals to access the data so that you can do analytics joining data. It should be self-service. We want to, and I will come to that in the next slide, increase the literacy of data across the company. And we cannot have central teams that are doing all of the analytics and doing all of the dashboards. You need to have a knowledge level and a platform that is easy enough for you to do self-service, basically. Easier said than done, but you have to strive for that. Common information models, of course, a key element in order to be able to join the data sources. Mean you need to understand how the one data element or one field in one data product has the same meaning as another one, and then you can join the data. And discoverability, as I mentioned, it's about being able, as a well-informed user through self-service, also be able to discover the different data assets that we have. The final pillar, the data literacy, it's about having a foundation of awareness of the value of data analytics, as well as courses and competence development in order to be able to raise the lowest level of knowledge across all the company. And we have a stepwise approach or a stairway here that we call the first step, know your products. It's about understanding your products as in a functional product, but also as a process step or a way of working. To know how that performs. You start putting perhaps measurement points or finding out where the data is that you need to understand the performance of your process or your part of the product. And how to improve it. And the next step, data without borders, that is when you combine your closest set of data with other data to create new insights. And for that, you typically need all of that, the governance, the data mesh principles, the ownership. And then a next step, AI augmented product development. Then we're talking about using like generative AI and other tools or advanced analytics tools to be able to improve your development process, basically. And the top level intelligent legal functions, that's where we put AI into works when it comes to the running functions in the car, basically. Right. So to conclude then, a federating operating model is really key in order to have the overall responsibility split across all of the company. Because again, you can't do this with a central team. You got to get out as far as possible to the specific domains where the value is created. The common data governance allows you to have an efficient way to operate the federated model in terms of having the principles and standards in place, to have the data protection and the data security elements covered in a good way. Creating the data products, that is about finding the right and the best owner that is ready to be knowledgeable and accountable for the data, and be that over time. Building a unified data platform, it's about embracing the mesh principles, that it will be a heterogeneous environment, but also building a golden path so that you can recognize yourselves in different data sources, do efficient analytics across many different domains. And driving the change to increase the data literacy is about both providing the basic understanding of the value of data analytics, but also to have in-depth trainings for those teams that are on the forefront here. So with that, I think we have a lot of time for questions or dialogue around this. Thank you.
Thank you so much, Niklas. And yes, we have time for questions, and I already see hands. So Hans,
Thank you, Helena. I'm really impressed by the system that you have built. That looks wonderful. But I'm missing one element. Whenever I've been involved in data projects, in particular when data has been collected from and combined from so many different sources, data quality was always a main issue. So what do you do about data quality?
Again, it really goes back to the source. So understanding bad data quality can actually be fit for purpose data quality, because you created the data, you captured the data with a certain purpose. And if that was enough for you for that use case, then that was the right quality. But as we go wider and broader with this, that data quality may not be sufficient. So in order to remedy that, you need to have this overall understanding through a way to expose this is the data, and have the requests and needs from other domains be guiding you as you further build up that. So I agree, we see that as well, but if you start looking at it, you understand it may be fit for purpose data quality to begin with. And then again, there may be also the fact that people are not using the data, and therefore they have not validated properly and verified the data quality. So when we put it to use, we expose it, it becomes painfully clear that we did not consider data as an asset or as a product. We considered it as a byproduct that we never looked at, and then the quality is crap. Totally right.
Yeah, thank you. So when I heard data as a product, the first thing that came to my mind is this holy grail in the automotive industry to monetize data.
Yeah.
That is going on very long already.
Yeah.
What is your view? Is this mainly is that a product for your internal customers? Do you see B2B use cases or anything that you can sell to your vehicle owners?
Yeah, good question. Right now, it's really 100% internal value. Internal value is in seeing data as a product, because it's about secure the quality, making sure the ownership and accountability, because there's so much value in just internally combining the data and making it efficient. Because yes, we have been using data for 25, 30 years already in isolated stovepipes like this. And we can continue to do that. And we have internal spaghetti pictures of showing how we connect certain data for a certain use case like that, but it doesn't scale. So data is a way to structure it and to raise the value of it internally. So this actually requires not only ownership and accountability and certain standards, you may need to rebuild the application, the transactional systems in such a way that they cater for thousands of simultaneous users, which was not the intention of that CAD system to have, for example.
we have Vito with a question over there, and then you
I understood your operating model, how we spoke, and I imagine that you have a counterpart managing the platform.
Yeah.
Do you know if they manage the platform also as a product? Can you share something about that?
Yes, absolutely. So that is quite clear. The product, the platform itself is a product to be handled with a roadmap, with a set of expected functions or features, priorities based on the different users, etc. So absolutely, the platform itself, the Unified Data Platform, is a product.
Thanks for the great presentation. I just had a question around Gen AI use cases that you're having around Volvo cars.
Yeah.
So can you walk me through a couple of use cases that you're trying to explore using Gen AI?
So we put together about a year ago a generative AI committee in order to both get a better overall understanding in the company what was all going on in that space, but also to minimize risks, to ensure that there was minimize the risk for IP leakage or infringement on others' IP, basically, which is a prevalent risk in Gen AI. Out of lucky combinations of timing and really good people, we actually got a very good traction of that. It took some time to get started, but we got as far as quite quickly creating sandboxing or guard railing requirements that allows us to actually unleash a lot of use cases with some basic principles of minimizing leakage of data and minimizing the risk of infringements. So today we don't have any code going into our products. We have it as supporting systems. And also we run those GenAI models locally in our own premises or with our own domains. But typically the first one and most used one is the GitHub Copilot rollout. So we have around 1,500 users that are using it, typically for as any university student uses it today, actually. It's a natural thing to use a ChatGPT or similar. So to write test cases, to get suggestions for validating a code, etc. So that's typically that.
Follow-up question. So apart from GenAI, are there use cases that you use deep learning or machine learning kind of infrastructure?
Yes, and that's typically going back to the safety systems, the zero collision submission that we have. And that's our colleagues over there, Sensact, who is our software supplier for ADAS and AD functionality. So they use deep learning typically for object detection and later on for deciding a most probable path or even a decision about the driving activity.
Could you elaborate a little bit about the golden path? I understand it as creating a data engineering or data analyst experience. And I'm also very interested to understand how far you have come down to the data contract dimension of thinking about data products and going to computational guardrails rather than guidelines and frameworks in the government. So where is your thought process here?
It's we are in the beginning of this journey, and we're coming from, as I guess many companies, a very heterogeneous situation with many different systems. We build one for the complete golden path for sensor data, for example. That's one with huge volumes. And then we have one system that is more for a bit low volume sales data and things like that. But one thing is, for example, the access and the access rights, and to ensure that if you need access to this and this, to combine it, you get it in the same way. The documentation as a part of making it easy when you create a new data product, store the data, to document it and make sure it's discoverable in the data catalog. And also the what we call the quality port in that, so that we have a harmonized way to monitor and tell about the data quality, for example, so that you as a user can actually make your own judgment of is this valuable or not for me to use given this quality level that is assured. And then talk about the contract itself, because there will need to be some sort of SLA, because in some of the cases we are doing ad hoc analytics. We are pulling data from different sources, we do a mashup, we do an analysis, arriving to a conclusion. But in some other cases, we have a continuous flow. It's an operational flow of say, a machine learning model that is running continuously with the data flow from different sources. And then you would need this kind of SLA for the data flow. And we're not quite there yet, but this is really something that will be important as more domains become more mature and building.
Andrea and then Martin.
You've mentioned the vehicle life cycle. I've spent some time in automotive remarketing, which is the sale of second-hand cars. And one problem that we've had is that data describing the vehicle stopped at the moment the vehicle left the factory. So I would be interested in hearing some of the things you do in order to make a vehicle describe transparently to buyers of second-hand cars.
Yeah, this is really interesting and important, and I think we have both a lack in the more static description. How is this how is this car was built, and how is what configured, and including with that also the functionality well described, because when that is in place, that documentation, then you can also build various ways to sort of inform about the functionality of the car. But what I think you mainly think about what is service history and things like that. Yeah, and we are actually now building, as a part of this, we are building what we call a vehicle journal, which is a history logbook, you could say, of all the activities that this car has experienced, both in terms of faults, workshop visits, customer complaint calls, or support calls. So it's a way to have a logbook for everything that's happened with this car individual, much in the same way as you typically have with a CRM system about a certain customer. So that is something, and with that, you also need to connect the master data. So given that there was a repair request at this point in time for that VIN number, that individual car, what was the software configuration of that car at that point in time? And that software configuration, what software, what code was that based on at the build time when that was built? So in order to full trace, to understand the full history, traceability, you have to have all your ducks in a row, so to say here, and have everything in order. So we're looking at the bigger picture, but we have to build sort of and fix step by step. Yeah.
I have a question that builds on this old joke of why building a car when what the customers really want is faster horses. Yeah. So the big consultancies claim that 80% of work will be either automated, augmented, handled by analytics and generative AI. That requires work to be in a digital form. So there is a huge transformation around this at the moment. So how can a company avoid making an electrical horse out of themselves? What they really want to be is some kind of amazing future digital car that's really custom for what automation, augmentation, etc. can do. Have you seen any tension or dilemmas around this?
Interesting reflection on that. I think that we see as we build and construct the car, the overall knowledge from the engineer will be leveraged with so many tools, so that you need to probably build the functionality at another level. You may not be building it sort of line by line anymore, but rather with building blocks and also from suppliers. And I guess that goes into the analytics domain as well, that you want to, it may be sort of a cycle where some analytical tools are so powerful so that you can use them and build on top of that, build certain insights that you would not be able to do by hand, so to say. Yeah.
Thank you very much. I have a little bit of an odd question. So I understood that you say different teams develop products, internal products. They are probably globally distributed as any company. But actually the profit comes to Sweden then. What does the tax authorities tell you about that? What do they think? Because it's actually a shift of IP.
Well, let's see if again, what is your point?
Sorry, I took the mic, but
So my point is that there's actually a shift of IP. The product teams, for example, in India or anywhere in the world, develop a product, enhancing the data, making sure that it's the quality that you can make something out of it. But what's happening is that the Swedish company, the mother company, so to say, are making the profit. That's a shift of intangibles. That's a shift of IP, which is actually taxable. That's why I'm asking what the tax authorities think about your like very broad network of platform of data exchange.
Yeah, if we just look at data exchange,
No, it's not the data exchange. That's the point. I think because if you just send around plain data, then there's no value in it, right? So as you said, it's with the quality, the circumstances, how they are collected, how they annotate it, if it's annotated data, and so on. So there's value in that, and it's probably generated somewhere on Earth, but then it shifted to Sweden, and here the profit comes. So probably the Indian tax authorities will tell you, well, actually the profit was actually generated in India and not in Sweden. That's actually the problem.
Interesting. Then it's you could then compare it to a more tangible refinement of from raw material to a product, and then you export that from that country, etc. And I guess that's that. This is not really my area of expertise, so I can't say that. But that would go for any company that are doing software today. I would say globally then, because you're
just for reference. That's what happened to Microsoft. Microsoft got sued a few months ago.
Okay.
Just because of that.
I
They shifted
know
exactly parts of Windows to Iron.
Yeah. But if we take even if that was not your question, but if we take the question of data, and that probably most of you know that there are so many restrictions about moving data across the globe today. So really, the way we need to build it here is to have the local competence, both to manage the data and to analyze the data. And this is not all have in the companies how you realize this, but you can't move data across the different regions. And it becomes more and more difficult because every company or every market in the world that wants to protect their own IP, for example, or sort of the national security, that they will not allow data to be moved. And also, of course, depending on the origin of the mother company, for example, so us as with Chinese owners also becomes a problem, where we need to show how we actually build our products and how we operate them in different markets. And we do have regional, say, cloud centers in each region.
We have two more questions and then we will take a break. So Stanislav.
Thank you. I have a question. I'm from the medical domain, and during the COVID, we see the picture that by sharing the data between biggest pharma companies, the speed of innovation really goes up. Especially in vaccines. I know that in car manufacture, the data is heavily guarded. Do you think that if the data can be shared between the biggest manufacturers, for example, that would increase the innovation speed and safety of pilots, stuff like this?
I think so. And in some areas we do share data. One example is to some data sets from our ADAS and AD development. We do share some LiDAR data sets, some crash data, etc., for research purposes. So not necessarily just between different companies, but also more in the public domain. Then if you look at another area is the traffic safety and traffic information. And this is also where we have decided since safety for us is so important for all society, we're actually sharing a lot of that data for free. So for example, near weather and slippery road conditions, that data we share with road authorities free of charge with the function that we have. And then if you extend it to the data owner, the user or the owner of the car, you may know that there's the legislation of the EU Data Act that will actually push all of the IoT device manufacturers to actually deliver more data and in a more machine readable and easy accessible format. So that will, even if the intention is not to harvest as the other companies should harvest that data, there is of course the element of that data being shared to service providers to provide a service on the data, and that in itself will allow other players to get a greater insight of the data and more innovation, which is the intention of that legislation.
Thank you.
Yeah.
Very last question. Yes.
Okay, thank you for getting the chance of asking the very last question. So I do it in ask a combined question, so it's more challenging. First, I would be interested in the use case. How much do you evolve the car when it's still already on the streets? So not like in the old days when cars are built, then they are sold, and as we heard before, on the aftermarket, nobody cares what happens anymore. But probably nowadays cars are evolving products.
Yeah.
And one example may be the assisted driving, where you collect data from the road, from the scenarios, and improve the driving systems. And coming from that, the second part, which interests me, is when you look at the data you have, how much is the timeliness requirements involved? And what are the extreme cases? How much real-time data you have, and what is kind of the cut-off point when the data is old? Do you still consider data back from 2 months, 1 year as valid, or is just don't care anymore?
The first question, 3 million. 3 million over-the-air updates the last few years. So yes, our products are getting better every day. Second part, when does the data get sold? I think never. You should be careful not to store everything just for the sake of it. But I'm expecting a certain piece of data out of the field will be a gold nugget in 3 months, 3 years, 30 years from now. Real-time requirements, for example, if we have a system like the sharing of traffic information, slippery road warnings, that has a latency of at least maximum a couple of seconds, because we want to warn the oncoming driver there. Whereas some data, again, for tracing back to a problem in some systems, 10, 15 years, pretty reasonable.
Thank you so much, Niklas. We could not have had that. And for the coming hour, after a great opening